Good morning and good afternoon to everyone who's joined us. Thank you very much for joining us today. This is the part of the Midwest U Speaker Series put on by ATG as part of their Midwest University from last year. The speakers not able to present in person. ATG has given us a platform so that we can still share the learning even though we couldn't get together, and we are certainly looking forward to getting back together with everyone. This session is going to be on splitting up is easy to do, dividing a large project. My name is Russ Nicloy. I am a civil solution specialist at Macer Technologies in Wisconsin. I've been in the industry for over 26 years. I think I told them 24 years for my bio and then realized that it's been a little longer than that. So 26 years, 10 of that in production. Quite a bit of that was actually with a reseller. So I got to work with a lot of different organizations through them, including Wisconsin DOT. And then recently, about three years ago, I started my own company, Macer Technologies, to provide drafting services to the civil and infrastructure industry. Now, I mentioned the Wisconsin DOT not because anything that you're going to see here is related to them. Some things will cross over a little bit, but I do want to be careful. Some people know me from my time at Wisconsin DOT and may think that this is coming from them, and it's not. This is a much broader presentation. It does touch on things that WisDOT does, but generally will not be about Wisconsin DOT workflows. So if you are involved in Wisconsin DOT work, make sure you follow their workflows and practices. Not everything that I say here today will be related to their work. So just a quick note about the agenda today. This session was born out of an observation that I had of users and many different organizations struggling with project size and slow responsiveness, and some just asking what they should do to make their projects more accessible or speed up responsiveness. One of the first questions I got about Civil 3D, and this would have been about 2005 when it first came out, was how to share project data. If all the design objects are in one file, like alignments and profiles, things that everyone on a project would need, and they're all locked down in one file by a single user, how would others work on the project? Well, now that's only half of the issues that I think dividing a larger project will address, but it is significant. And you're going to see that come up throughout the course of the presentation. As Civil 3D has developed over the years, the need to divide projects certainly hasn't gone away at all, but the ability to do it cleanly has grown. And they've really put some focus on it. So that's what we're going to shine a light on here, is to make sure that you feel comfortable in dividing up a project as appropriate for your needs. So with that in mind, the agenda that we're looking at is first of all, why split up a project? Is it a good idea? There are some projects where you won't need to or won't want to, but what are the good ideas behind splitting up a project, and when should you do it? What makes splitting a project work? More conceptual things about how, what things do you need to make sure are in place to make sure that the splitting will work? Where is it best to split a project? Because just picking a point at random is not always the best approach to something. So you want to kind of plan out where you're going to split the project up and communicate that to the rest of the team if there are more people involved. Then we will also take a look at confirming that the splitting and rejoining is working. Now, we will talk a little bit about splitting the project up into separate files, but at some point you may need to bring them back together again and make sure that they are rejoined. And you need to confirm that that's working, and that things, as you make revisions, that your files are all staying up to date and all staying synced up together from the very beginning design files all the way through to your deliverables and everything in between. It is important with Civil 3D that everything is communicating correctly. So with that, we will look at why is splitting up a project a good idea? First of all, if you have multiple team members working on a project and you need them to be concurrent users and maybe working on different aspects of the same project, but really one user locks a file down, by having it open. So splitting a project is almost a necessity at that point. This may not be as broad as I'm going to take it. You may find that, well, only the alignments and corridors need to be, separate files, but we're going to take it an extra step and say that, even the corridor is too big for one person to be working on. We're going to divide that up further so that more people can get access to it, and especially during crunch time, be able to get in and get some work accomplished. In the case of a single user design, you could argue that, well, yeah, we don't really need to divide up a project. However, I think there are reasons why a single user could. In fact, in my Macer job, I am doing project work, and I am a single user shop, so I'm not sharing a project with anyone, but I routinely use data shortcuts and some of the things that you'll see in the presentation today to divide up a project, even though I'm the only one using it. One thing is the files could run faster. Now, notice I'm stressing could, because not all slowness is based on the project not being split up. However, generally they could run faster if it's not constantly updating everything in the project. Also, styles are controlled per file. So I can have a surface with a certain style of contours in one file and a different style of contour in my deliverables or in another working file. That's another great reason. Another reason I really like the data shortcuts is they allow you to make things look the way you want them to look in disparate files and other files. Also, creating separate plan and profile or cross-section sheets makes those files cleaner, but it makes those deliverables easier to work in and digest, and also hopefully, again, going back to the first point, hopefully move a little faster since they don't have everything in those files. And also maintaining project standards. Even though I'm a single user, many times I'm working with an organization as part of a team, and sometimes I find it easier to just keep working with the project standards and divide a project up as I would if there were more users, so that I stay in that kind of rhythm and continue to keep things clean and accessible. Also, if you're a single user on a project, other people may come to look at it later or consume it later, and having it divided up in a way that they're familiar with can be very useful. So something to keep in mind. I do want to kind of go back to that first point in the fact that each file could run faster if it's not constantly updating everything. And for this, I want to look at not only the data references, but the fact that XREFs have been a big part of design files for, I'm going to say decades now, as well as sheet and layout tabs. There are some things that everyone should be aware of and concerned with, but should drive the way that you work in a project file. And that is, if you're working with XREFs, if you're used to working with XREFs from just plain AutoCAD, those files don't do as much computation as Civil 3D does. Civil 3D does a lot more computation under the hood through XREFs than what an AutoCAD file does or needs to. The AutoCAD developers have opened up some parts of XREFs so that Civil 3D can share corridor shapes and surfaces, so you can do cross sections. In fact, for a while there, that's how we had to do cross sections, was XREF your corridor into a file and do it from there. I literally an hour ago just talked to somebody who was facing that very thing. She was concerned that her XREFs were taking forever to update, and explained to her that Civil 3D is doing a lot of stuff under the hood here. So this I'm literally an hour ago I was on a phone call, so this is really front in my memory right now. So something to be aware of there. Generally, and notice I say that DREF is better than XREF, generally so. I'll come back to that statement in a second here. Data references also reduce clutter in design files and plan production files. And what I mean by that is, if you XREF something into a file, you're bringing the rest of that file with it. And so if you have any typical sections or little detail drawings, or usually it's profile views that you have sitting around in the first file, if you XREF that into a file, those all come with it. Now you can XREF clip and clip that out and kind of trim it down, but you are bringing that data over in the file. Deref, data references, data shortcuts only bring over the geometry of the object. And as I said earlier, you can make that object look however you want, the styling and the labeling and so forth. So in my mind, I think data reference also takes this one as slightly better than XREFs. Now, on the other side, if you have to XREF, and most projects need an XREF at least at some point, attach the XREF but unload it so that you can have quick access to it when you need it. If you don't need it all the time, if it's not part of the deliverable, you just have it as a background reference, unload it so it's out of your way and you won't get confused about the lines you're looking at. Then reload it very quickly when you need it, unload it when you don't. It's a quick back and forth that you can do with XREFs. Now, in terms of the sheet layout tabs, I think it's best to have separate files for the sheets. So again, they stay clean and they stay focused on their production value. And layout tabs in general, the more layout tabs that you have in a file, the slower a file will work. And I'm talking like 25 to 40 or more layout tabs. You're going to see a significant reduction in responsiveness in a file. So I think it's best for other reasons besides planned production files. But if you have layout tabs at all, keep those in a separate file and use the project breakdown or split to facilitate that. Now, in those cases that I claim that DREF is better, you see it right there on the screen, it's better than XREF. I know that's not the whole story. You have specific project information that you need to XREF. Sometimes things don't data reference and you need an XREF to bring them in. I'm not saying that you shouldn't XREF, and I'm not trying to downplay its usefulness at all. It's just that when I have a choice, I recommend going to data references if we can, but that's not always possible. So another question is, should I split even the smaller projects? And I'm going to say that data shortcuts are good in small, medium, and large projects. XREFs as well to some degree as well. So yes, you can split even the smaller projects. I was working on a project just a couple of weeks ago. Literally the road was 300 feet. In fact, we ended up not even using a corridor for it, but I still split it down into alignments and existing surface versus proposed surface, because then it was accessible and we could move things around and stylize them differently. So there are reasons to do a small project, but you don't necessarily have to. Now, where I would draw the line is whether you do a separate corridor file or not. You'll see in my demonstration a little later here that I have a fairly small project. In fact, one I would probably not split into two files, but I want to use it as an example. I might not divide a corridor up if it's small enough. If it is just a couple of 100 feet, if it's less than a mile, perhaps I'd keep it all in one, or not very complex. Maybe there's no intersection involved in it. I wouldn't necessarily split that out. Because if you have fewer team members and smaller projects, really, you're getting less of a benefit from splitting that out. Now, as an example of a small project over a large distance, this is one that happened a couple of years ago. It was one user. The project was 47 miles long, which sounds gargantuan. However, it was a beam guard project, and there were only a couple, I think it was like 16 different areas where there were beam guards along that 47 miles. So only a couple hundred total feet of design across the entire project. We did use data referencing for the whole existing and profile, because that was useful to have one alignment and one profile defining the whole 47 miles of the project area as they hunted and found where they needed the beam guards. But then we created individual corridor files for those short little beam guard sections. That way we did have, I think it ended up being eight files for 16, and one on either side of the road in most cases. And so a small project, but the distance seemed like a large project, and it still was only one person. So, so there are some real reasons to divide up a small project depending on what your situation is. So what makes the splitting work? In this case, I think above all, the alignments and profiles, because they can stay consistent through those splits. I just referenced that 47-mile project. one alignment, one profile, and it was consistent through all of the design areas that we were making our way through. That way you didn't have to keep creating alignments and profiles and separating those out. One alignment, one profile, that way. And as the screenshot below, the little artwork there kind of is meant to imply, if you are not lined up in the horizontal on the alignment or the profile, the profile in particular will create an escarpment where those two meet. So if you have a consistent alignment and profile, you can avoid that very likely situation that you'd get into as you're trying to line these different corridor sections up. So baseline primarily, but also for targets. Alignments and profiles will play a huge role in targets, especially where you're splitting the project. And again, consistency in the targets is almost as important as the baseline in those particular areas. Then the data shortcuts of the alignments and profiles, again, make this work. Sometimes surfaces can help, existing ground in particular, but there might be some other surfaces in the neighborhood of your project that could also help fortify what you're doing on your project. Now, I recommend some file that allows you to recombobulate your file. And this is my new favorite word. Anyone who's flown through Milwaukee knows that the security area has a recombobulation area. Literally, there's a sign up. It's an official location. So if your file is, I don't want to say discombobulated, but it's many pieces there, but you need to make sure that they can come back together correctly. I recommend having a file that is separate from all others that you can recombobulate or combine them. Now, here's where we do touch on WSDOT. WSDOT, for those of you familiar, they call this a refinement surface file. They do one for the top and datum and whatever other surfaces you might be using there. But those refinement surface files are meant to recombobulate or recombine those surfaces. I'm going to refer to these surfaces as combination files, specifically so that I'm not always referencing the WSDOT workflow, although we do touch on it here at this point. What you want to do is data reference all of the corridor surfaces into one file and then paste them together and then check for the edges to make sure that things are working there. So that combination file is kind of like the back end check to this. And again, makes this process work. It's a key ingredient to success in this process. So with those things in mind, where do we best split a project? And I tend to say generally here, but really what we're going to do is where the project has the minimal amount of change. Now, I'm talking, if you've got intersections in a project, those are the most complex areas, or generally the most complex areas in a project. You might have other complex areas. You want to avoid complex areas or places where there's a lot of change because things don't always line up great in an area of lots of change. You want an area that's more consistent. A very boring part of the road in between two intersections is a great place to do that. Also, I would avoid any areas that have grading because grading is usually not consistent. It's coming off at what could be different angles and could be not as prime for the kind of split that we need. Like I said, we want to divide this in a clean area. Now, I have seen projects where grading was a predominant part of the design, and it would be very difficult to split anywhere else. Find the best place in a grading if you have to do it there. Try to make it, in my next point here is going to be perpendicular. Try and find a place that it would be perpendicular and a little bit more consistent for the two areas to be matched up. I'm also going to recommend that you avoid sample line stations, not because it's an actual problem, but because it might, if you're going to have any trouble at all with this, it will be where the 2 points join, and you don't want that to be at a sample line station where it's going to report weird information onto your cross sections. Now, as I set this presentation up, I realized in my demonstration, I break that rule and I put the split at a very nice and even station, probably where a section line will go or could go. So it's not a hard and fast rule. I am willing to break it myself, but it's just a recommendation that you put it in kind of a side area, maybe a little bit off the normal 100-foot station locations. Now, as I kind of alluded to and wanted to allude to the entire section up there, perpendicular cuts are best. In fact, this is where I almost say generally, but it is absolutely how Civil 3D works with corridor design. Whatever your baseline is, your corridor is coming off of that perpendicular. Now, it may not be perpendicular where your targets are or other places in your design, but at your baseline it is. And really, that's what we want to focus on for the cut. If you do angles, and you could do them. I do recommend you do them along alignments and profiles, along baselines, or targets. You keep them all in mind. If you have to do them at an angle, it will change the way that you build the corridor because of the way the lanes have to cross or the grading has to cross or what have you. So you do want to be careful to maintain a perpendicular cut. I was going to say wherever possible, but absolutely, it's really, I think, a requirement. So the last thing I want to talk about here before we get into a demonstration is confirming that the splitting and rejoining is working. I am going to touch on the rejoin process here. Really what we're going to do is confirm it. Whether you use this combined surface as a deliverable or as part of your deliverable or not, you may want to create that side file so you can create the combined surface and paste it together just to double check things, even if it's not going anywhere else. So create a file that you can create a combined surface and paste those two surfaces together or multiple surfaces together. I have two in my presentation here. And turn the contours on because nothing shows abnormality like a contour. If there is any deviation at all in horizontal or in vertical in profile targeting, contours are going to show that immediately. And I think you may even be surprised. You may expect to be. I'm always surprised when the contours are so smooth in an area where I know there's a seam. So it's something that you can check very easily. You can also use profile views to do this, and might be a good idea if you have a lot of elevation design going on. Create a profile view of the surface and the area that you're doing the work in and check to see. I think this is a little harder to tell because the differences could be slight where the contours would show, but the profile view might be so small that you wouldn't necessarily see it. I'm talking inches rather than feet. But if it is off by feet, you would see an escarpment and know that there's a problem there. Basically, what we want to do is where the corridor surfaces are stitched together, or where your project surfaces are stitched together, there's no seam visible, or there's nothing visible to anyone that is how you put them together. Now, I do want to say, do you even need to rejoin the surfaces? I'm going to recommend on some level, yes, but maybe not for your deliverables. If you're working on a project that cross-section sheets are your deliverable and you're not going to split your project at a sample line location, then maybe the cross-section sheets are enough. And as long as those are good, it doesn't matter if you're off by a couple of inches up, down, or sideways at the join point. Also, plan and profile sheets, like I said, can sometimes get away with a little bit being off at a seam point, but you couldn't be off by much. But if your deliverables are things that not knowing if the rejoin worked, then maybe you skip that. I'm going to recommend it again, just as a back end check to make sure things are correct. One of the things I've noticed about Civil 3D specifically is that we can no longer just explode and draft over something to make it right. We really do need to concentrate on making the project correct and almost digitally developing something like we will in the field. Not in every nook and cranny perhaps, but generally if you want something right, you need to go in and do a little extra work to make sure that it is clean and correct, and exploding and drafting over is just not going to do that. So now let's swing over and take a look at our presentation, or the demonstration, I should say. I do want to point out that I'm using Civil 3D 2022. However, everything that I'm doing in this file will work in previous versions. In fact, I don't think there's anything that I'm going to show here that you couldn't do in 2016, 2018, 2021, all the different versions here. So What I've got is a project between two intersections. And I said, it is a fairly short project. I might even try to accomplish this in one file and not split it. I do have the surface existing conditions, the alignments, all the alignments and all the existing profiles in their own files, and they are data shortcutted into the file. So I've already practiced what I'm preaching here of splitting the file up that way. I do want to call something out real quick, and this is something I did learn from Wistat, but I think works for everybody. The existing ground profile is here. It is data referenced in from my alignment profile file, but this profile here is actually in this file. I'm designing it here where my intersection is. My plan is I'm going to use the intersection tool here, and that will mean that that proposed alignment will react to the intersection tool. But to have that reaction, you need to have it in the file. So I do my profile design work on my side roads in the file with the corridor, the intersection. The mainline profile here is in my alignment profile file and is data shortcutted in here, as well as in my east version. You can see here, I've already started creating my corridor. I have started the east side of this through discussions. We've discussed that the project should split here. Let me zoom in so you can see where that is. It's at station 126.00. Like I said, probably where a sample line will end up. I should have split it at 126.13 perhaps. But that is where this project is going to stop. So the east side of County Highway E has the corridor and intersection up to that point, up to 126. I'm going to go back to the west side here and develop the intersection and the design up to that station and stop exactly at station 126. Stopping at a very granular, very precise station is, I'm going to say, mission critical to what we're doing today. You might be able to get away with it, but I'm going to say I've never tried to get away with it. So I'm going to come up and choose the intersection tool. I'll create intersection here. I'll do this quickly, but I wanted to show the process going through here. This is my County Highway E and a River Road intersection. So just so that I know what that intersection is when I find it later. I'll go next, and in here, just want to make sure that the profiles are both there because we are building a three-dimensional corridor here with the intersection tool. I'll go to the offset parameters, and my defaults are not set to the width of my project, so I am going to set those. These are all 15-foot roadways here. The curb return parameters, I'm not going to change. I just want to touch on it that's part of what makes this so complicated is the turn lanes, whether you're expanding the lanes and that type of thing. So I'm going to say okay and just accept the defaults for today. I am also going to look at the lane slopes. Those all look good. And I'm going to confirm the curb return is giving me 25 extra feet on the profiles so that the corridor, when it's built, doesn't miss any stations by a very, very short amount. 25 feet is plenty to cover up our design there. When I go to the next tab here, it gives me the opportunity to create a corridor. Now notice there are no corridors in my west file. The corridor I showed earlier is in the east file, so it's not in here. They are completely separate, completely new. You can add this intersection to an already existing corridor if you need to, if you wanted to, but I'm doing a fresh corridor in this file using my existing ground as my target, and these are the assemblies I'm using. I'm basically using the default assemblies to build this corridor. I'll say create intersection, and that will kind of grind away for a little bit. And there is that corridor. Now, the corridor is actually more than meets the eye here. If I come down here and select on this, one of the best practices I think that should be shared with everyone is when you're building anything that has intersections, build the intersection or the more complicated design first. And then the rest of the design is easy. In fact, I'm just going to drag my corridor out here away from my intersection, so that I can see that that design that I ended up at the end of my intersection is just going to continue on. The downside is because I told the lanes to be 15 feet, they're targeting 15-foot wide alignments here. When I move past that intersection, The targeting stops here, and you can see I've dropped down to 12 feet. My assembly had 12-foot lanes involved in it. So I'm going to hit escape, and then I'll select the alignments that are targeting on the outside edges there. I'm selecting both of them, grabbing the diamond grip point because they both will move together. You can see that they're moving together there. Now I'm going to move these down to make sure that I'm past 126. In fact, I'm not going to go to station 126. I'm going to go well past it. This is one of those cases where going further, way further, is better than going any amount shorter or directly to it. The corridor will end where it ends, but the targets I want to be a little bit further there. Now I'm going to come back here, and you saw me drag this out earlier. I'm actually going to go into the corridor properties. And in here, I'm going to minimize all these so I can see which alignment baseline I'm on. I'll expand that baseline. Notice it's highlighting in the screen. That's what I'm looking at. The regions here, if you click on the regions, they highlight. And I want that last region, the region that includes the end of it here. So I'm just confirming that. And I'm going to go to tell the end station of that region to be 12600. 12600. I'm going to click up. I'm going to click OK so I can rebuild that corridor. And you'll see here that lane is now, there's no longer a 15 to 12 foot jog anymore. It's going all the way down to 126 over here. Now, I am actually going to go back into the corridor here. I'll select the corridor. I'm going to go to the corridor surfaces, although this will be in the corridor properties as well. The surfaces tab, I'm going to build my top corridor surface. So this is County Highway E West. I want to call out that this is the west surface top. And I'm going to change the overhang correction. I'm going to use links and the top code to paste that in. Then I'm going to click on the surface again and create the County Highway E West datum surface. And come back with the links and add those datum codes in there. I'm going to turn on the add break lines for the intersection. That'll clean up the intersection surface area. And I am also going to add in boundaries here, just using the corridor extenses outer boundary. It's the easiest way to do that. And it is quite dynamic later on when we're building or revising our corridor, I should say. So there is our corridor and our surface. Top surface in particular, the datum surface is here as well. I'm going to click save on that. And then I'm going to go over to, not only did I have the west and the east, actually I need to go into the, stay in the west here for a second. I'm going to come down here. I need to save the file for the data shortcuts. I am going to make the data shortcuts in here. Great thing about data shortcuts is they keep things up to date, so you can create them very early in your project and not worry about the revisions not keeping up to date. So I'm going to bring in both of those surfaces. I probably should bring alignments, but I'm not going to today. I am going to bring in the corridors in case I want to use those a little bit later. Like I said, cross-section sheets in particular, it's a great thing to use. So I'll say okay to that. You know, those are available. I'm going to switch over to my County Highway East or Corridor East file and hit save and create the data shortcuts for that as well. And I've already built those surfaces here. I just didn't create the data shortcuts. And again, I am going to bring in the East corridor here as well. Now with that, I'm going to go over to the final proposed surface and do that combination file or recombobulation file. There's nothing in this file currently. I have built the surface that will be my combined surface. I called it unified top surface, but there's nothing in it. There's no definition there yet. I'm going to come down here to data shortcuts. I'll expand surfaces, and I'm going to bring in the east top. Right click on that, create reference. And generally when I do this in a combination file, I bring it in as no display. Now I'm actually going to go in and change that. I am going to bring that in as border only, just so that you can see what is in the file before we rejoin them together. I'll say okay to that, and then I'm going to zoom extends. So I get back to the project. So here's that east corridor. Here's station 126. I'm going to zoom in on that area there. I'm going to come down here to the west top and create reference. And again, border only, I'll say okay to that. I'm not going to bring in the datum surfaces. I would do that in their own rejoin file or combination file. But here you can see they butt right up against each other there. There is a seam between those two. Now, this is literally what I do when I rejoin them. I make sure that those two surfaces don't have any style. Like I said, generally no display. That way, when I paste these surfaces into the combination file, I am looking at only the combination file. I'm not having to decipher which surface I'm looking at. I'm going to come under the definition here, right click on edits and paste surface. I'm going to paste in the east top. Normally pasting surface order is incredibly important. In this case, because they're not overlapping, in fact, they're coming in and meeting exactly, it doesn't matter which one we start with. I'm going to start with the east one. In this case, there is that corridor there, or that surface, and I'll paste in the west there. And this is the part that still blows my mind. Even though they are in two different files, two different designs, because the alignment and profile are the unifying factor here, there is no way that you can tell where station 126 is without an alignment. And if you zoom in there, you will see any kind of little hiccup very, very easily. So I'm looking at this and like, yeah, this has worked. I can now move on. I am going to hit save on this file, and I am going to create a data shortcut for this in case I need to send it to cross-section files or volume calculation files, or using that surface for anything else that is now available to us. So with that, let me sneak back here to my slide deck. And let's take a look at how we make sure that the project stays up to date through revisions. This is important because revisions never end. Every project as it's going out the door is being revised, or at least that's been my experience. So the revision process is incredibly important for the design areas as well as for the deliverables that you're going to have. You need all of them to be correct. So we want to maintain a single source of truth here throughout the project. So the objects are all defined once and then referenced in multiple locations. That way, if there's any change to that one definition, it updates all of those references wherever they may be. This calls on good data shortcut management. And you may have to fight the urge, but do not make copies of an object in another file. No promoting of data references, because that breaks the connection back to its definition. It will make the object there. It's basically making a copy of it. But if the definition is updated in its file, it does not update a promoted data shortcut. By the way, there are times when you're handing the project in and it's required that you have to promote. Obviously, in those situations, the project is done and you're handing it off within a matter of minutes or hours. You can promote then. I don't want to say that it's an absolute, but during the course of the project, as the project is being developed, you should not be promoting in cross-section files or in plan and profile files, that type of thing. And basically, no making unreferenced or disconnected object definitions. That's a critical part of what make data shortcuts work and what make splitting projects work as well. Corridors can now data reference, which is great for cross sections. It's great for other things as well, but in particular for cross sections, you don't need to data reference in and bring in all that extra baggage. The data reference is a great way to represent the corridor shape in cross section files. And of course, XREF where needed. I don't want to belittle that. It's still a need. So make sure that you are XREFing and using good XREF management process as well. You need to make sure that your combination file is staying up to date, because just making the changes in your main file and hitting save, that does a lot of work. However, you need to go over to the combination file at some point, and sooner is better than later, because you'll forget, or I will forget. I shouldn't say everyone will, but I will forget. And if you're not checking the combination file, you may be surprised that things didn't keep up to date like you expected. Now, And I say there, especially if it affects your deliverables, because if you don't look closely at your deliverables, you may not notice that that small little change did not get propagated through to it. So check your combination files, check your deliverables for changes that are made. The data references do update the objects in your combination file. Two sets of information here. If the combination file is closed, when you open it, it will sync and you will see the up-to-date information. If it is open, like it is in my demonstration files, you will have to sync it manually. And that is only part of the issue. Syncing is only part of this issue. The other portion is my surfaces need to be set to rebuild, or I have to rebuild them manually. This is a time when rebuild automatic may help, but rebuild is a critical phase of this. As I prepared for this presentation, every time I did this, I forgot to hit rebuild. And I was like, why is the surface? Oh, that's right, I didn't rebuild it. It literally is true to the issue that I'm highlighting here. So also, you saw me save the combination file. After you make sure that the combination file is up to date, you want to make sure you hit save there. First of all, because the file is probably in use somewhere, you need it for something, but also that will push the updates further on down the line into your deliverables or other places that that combination surface is being used in. So let's go back to Civil 3D and take a look at this. Actually, I'm going to go over to the West file here and make a change to it. I'm going to come over here and I'm going to grab those target alignments that I have here and drag that back. For whatever reason, our design is now requiring us to have a 12-foot lane after a certain station. Now, this is going to be a very rough cut, but I'm doing it here because I noticed some ditching here, and it'll be very, very obvious where this cut is. Just kind of eyeball this, memorize that location. And then I'm going to select on the corridor and rebuild it. That will update the surfaces, both the top and the datum there. Notice the corridor continues on, but we now have that 15-foot to 12-foot transition, very sharp transition there. I am going to hit save because that will push the data reference of the alignments back into my combination file. I'm going to repeat similar steps here in the East file, pulling the target alignments back. And I saw another ditch over here, so that's going to be a great place to do that. I will select on this. I'm going to right click and rebuild that corridor. And again, I am going to save it after it's done. And you can see quite stark there. I'm going to hit save, so that pushes that data over to our combination file. And now, as I said, if the combination file was closed, it would automatically rebuild. Now we should be, synchronize, I should say. We should be seeing a big balloon here that's asking me to synchronize. Somehow I turned my synchronize off and I forgot to turn it back on, but the button is still down here. Or you could come up to the Manage tab of the ribbon and use Synchronize References here. A little bit easier to see in a webinar, so I'll use that one. Now, as that happens here, watch this spot right here. Oh, and literally I did it again. Watch the spot right here. Oh, wait, I haven't rebuilt the surface. You're not going to see anything. So we're still seeing the old ditch line in that area. If I expand over the surfaces, the data shortcuts were done, but this surface here has those surfaces pasted into it. So it says, wait a second, my definition has changed. Do you want me to rebuild? I'm going to right click and rebuild. Rebuild. Now, there is this rebuild automatic. For this file, for the combination file, I think I do recommend the rebuild automatic. It's worth the time and effort. I do kind of stay away from rebuild automatic for surfaces and corridors, just because if you're making nickel and dime changes, they can take a long time, and it kind of adds to the time when you have to manually or when it's automatically doing it between every little change that you're making. So I am going to just manually re-update this or rebuild this, and you can see that change has now taken place here. Again, except for the contour lines where we're going from 15 to 12 feet, you can't tell that there was any, I think it's in this neighborhood in here, you can't tell that there's any seam through here or any division that went on there. So with that, and true to form, I've already created the data shortcut for it, so I'm going to click save there. I am actually going to create another file real quick here. And I'm going to go to the data shortcuts and bring in the corridors. Like I said, this is for the, maybe for your cross-section file or for some other need, but I'm going to right click on corridor. That's my east one. I'll create a reference of that. When you create a data shortcut reference of a corridor, it brings in all the alignments and profiles for you. So I didn't need to do those individually, but it will bring those in. I'm going to, once it's done here, it's done bringing that in, I'm going to zoom extend so you can see that there, style issue there, but otherwise we've got a corridor here. I've got the corridor style set so that we don't have the frequency lines showing up, but you might turn those back on. This is a corridor in all respects, except you can't edit it. If I select the corridor, there is no grip point here, but I can go into the code set style or into the corridor properties, into the codes here, and tweak codes or feature line styles here. I'm going to bring in the west one. Now, I forgot to change the name as I brought in the west one, so it just says corridor 1. But you will see here that as those get put together, by the way, if this is a cross-section file, we do have the baseline alignment here that was brought in with the corridors. Here's corridor west, here's corridor east, and you can see that line in between them. But you can create those sample lines off of the alignment that's in here. It's a data shortcut alignment, just like any that you would create or create in here. But now that project is also here as corridors being joined together. So let's go back to our slide deck. And with that, I do want to say thank you to everyone. Thank you for spending your time with us today and making this presentation something that people will attend. ATG, want to thank ATG for hosting this and for hosting what was going on at Midwest University in this COVID-friendly environment. So with that, I do want to answer questions or open it up to questions. I am going to click on the Q&A panel here. I'm going to pull it off to the side just so I can read them. If it were an existing road being rebuilt, would you still build the intersections first? That's a great question. I think that might be situational, might be what else is going on. What does the intersection look like? Generally, I go to intersections first because they're more complex. I like getting the complex things out of the way first and then expanding from there. But you could certainly argue me out of that. I'm probably 50-50, maybe 60-40 on doing the intersections first. So another question, are there limitations with using data reference surfaces that was created from outpasted surfaces? Not that I'm aware of. The only thing is that you need to make sure that the surfaces that defined the pasted surface are all updated and everything is being rejoined correctly and you've checked everything. But I haven't seen any limitations. In fact, the beauty of this whole thing, and you can use this in other areas, is that if you paste surfaces into a surface, it knows but automatically. I mean, you can't turn this off, in fact. It knows what surfaces are pasted into it, and any changes to those surfaces will automatically go over to that pasted in surface or that joined surface. Now, this question may have come in before I did show the rejoined surface and how that, how I had to rebuild it and so forth. But that really is instructive of how pasted surfaces and data reference surfaces can work together in other areas as well. How would you handle pipe networks through the splitting point? Is it worth trying to properly connect structure pipes on either side of the splitting point? I've heard that 100 parts is a guideline for a maximum number of parts per drawing. Again, great question. And by the way, it kind of touches on something that I touched on but didn't really call out. Having a rule of thumb about how much you have in divided out files, I think is important. In the question here, it calls out 100 parts in a pipe structure network. And you will find your number for 100 parts. I think is a good guideline. That's enough to make it busy, but not enough that it's going to overwhelm it. I'm sorry, for corridors, I'd say about a mile. So if I have a 3 mile project, I'm probably going to divide it up into 3 different files, 3 different corridor files. But you could talk me into a mile and a half and mile and a half, so only 2, depending on what's going on. Now, back to the question though, how do you handle the pipe networks being split? And that also depends on the situation. Honestly, I would take the rejoined surface file and put that into my pipe network area. If we're talking about pipes, a small amount of pipes in a larger project, I guess, less than 100 parts, then I would use the rejoined surface. That way my pipes don't go out from underneath it by accident. Now, if you're worried about pipe networks being too large, I usually do a structure. Now, that being said, I'm trying to think if there's I feel just as nervous about the second file having a copy of that structure or not having a structure at all. Basically, you will want to have the pipe responding correctly to the structure. But I think they're as separate from the corridors, you have to be even more careful with pipes and how you split them up. Kind of like the grading areas, they're just not as consistent, and it's harder to split those up. I try not to split them if possible, and so far I've been kind of lucky not having that large of a project that 100 parts was a problem there. Does the file hosting the combined surface need to be opened in order to update changes from the smaller component surfaces? And I believe that's a no. However, I would still check. First of all, you have to, if you're not going to open it, you have to have had Rebuild Automatic on. And I don't know if it's just my memory, but my memory is not good enough to remember what I have Rebuild Automatic on and what I don't. Also, I like to just click and see. I'm a kind of show me, don't tell me kind of person. So I do go in and check, kind of making this moot. I always open in order to update. I don't think it's absolutely necessary, but to protect yourself, I think it might be worth that. Another question here. Are there any limitations that you found using a deref for the corridor when creating cross sections? Boy, I'm sure there have been, but they would be, I'm going to call them minor. I'm sure for those that were doing it, they weren't minor because we had to kind of make adjustments, but I don't remember anything that was show-stopping or a problem. The person that I was dealing with an hour ago, and it was helping somebody with a project, and I tried to get them to deref the corridor in. Turned out they were in 2016, so we had to xref it in. Obviously, that kind of a game changer there. But if you're able to data reference in a corridor, I don't think there's any limitations to it that I can think of. And I apologize, I'm not dodging the question. I just can't think of anything there that would be an issue. So I would definitely try it first. Even in the most complex projects, I would try that first for cross sections, because I think the results are faster and they're easier to see, and they're easier to work with in most situations. So what do you recommend using for surface data reference status? Geometry stored in drawing or reference only? Wow. And again, I don't want to dodge the question, but I don't know that I have a preference there. I honestly go with the default on that option. And maybe I've just been lucky, but I've never had to make that choice. The projects I've worked in have never needed that choice. Trying to think of the consequences of both here. Boy, I think geometry stored in drawing, but I don't know. I'm almost flipping a coin here, so I apologize. I don't want to go past the question there, but I don't know that I have an answer to that. So By the way, we have a little bit more time left if anybody wants to type in a question there. Um, I do have the QR code on the screen there. If you hit that with your phone, it will put your my email information into your email tools, or just write me at russ.nicloy@macertechnologies.com if you have other questions that we're not addressing here, or if you prefer just to email me a question later on, I'm happy to address that. So, any other questions? Let me check. Oh, somebody did have a question in the chat box here. Sorry, I missed this. Your webinar focuses on roadway design. Any different instructions for land development design? Um, it gets really, really tricky. Now, I'm going to subtract the land development design that people do with corridors. I mean, I've seen people do it. I'm sure I've done it in the past here or there. I'm not a fan of it, honestly, because it's not as consistent. Um, I'm almost thinking that a land development design, you're almost a little more free because you don't have the perpendicular restraint that a corridor would. You can make the land development at a bit of an angle, or actually loop around things. Just thinking of projects that I had to like split around a pond. You know, we had a pond grading, and we wanted to make sure all the grading was in one file, and the rest of the file was in another. Um, that can get tricky too because you don't want to cut too much and make the grading not work. Um, so yeah, I don't know that I have any different instructions there. Uh, Planning the split ahead of time, uh, planning the split. Boy, I know I've done it where I've taken an over large existing ground surface, define it in one file, data shortcut it into another, and then create an existing west and an existing east, pasting the existing ground into both of those. Again, any change that happens to the existing file would happen to my east and west versions of that. Um, and then those would update as well. Then you could do the different gradings in the different areas as you need to. Um, I did just hand in a project a couple weeks ago where the surface was so large and so varied. We had 3 people working on it that we did have to divide it up. And really, it was just, and again, I know for a fact that we divided up through a parking lot that was not being touched. We had some stuff to the north, some stuff to the south, but the parking lot in between was was going to be consistent and not graded or not touched. So we did divide it through there. I think that would be my recommendation there. So thank you all. Some really nice comments in the chat here. Thank you very much. I appreciate that. Um, if there are no other questions, like I said, please email me. I do absolutely want to thank everyone for their time today. I know your time is precious, and for you to take an hour out here, I really hope that you learned something, found something. Maybe you knew some of it, but learned a gold nugget here that you can take back to your projects. And I do also want to thank ATG for not only for Midwest University, but for having the speaker series so that we can continue to share data until we can get back together after this is all cleaned up. So thank you very much, everybody, and have a great day.